So for this task, first we're going to read the problem. So Mr. and Mrs. Gloop want their son Augustus to do his homework every day. Augustus loves to eat candy, so his parents decide to motivate him by giving him candy each day that the homework is complete. Mr. Gloop says on the first day he wants Augustus turns in his homework, he wants to give him 10 candies. On the second day, 20 candies. And on the third day, 30 candies. So first I'm going to model this with a table. So I'm going to put day and then candy. So I'm going to put day 0 there just in case you start from 0. But day 1, he gets him 10 candies. Day 2, 20. Day 3, 30. Now I notice here that this is arithmetic because I'm adding 10 candies. So to write my recursive formula, first I'm going to write the general formula. U sub 1 equals blank, and we're going to fill that in. And then U sub n equals U sub n minus 1, and then plus D. Now, from our problem, we know that U sub 1, the first term, is 10. So I'm going to write U sub 1 equals 10. And then my common difference is also 10. So U sub n equals U sub n minus 1 plus 10. And then for my explicit formula, we are going to start with the first term. So we have y is equal to u sub 1 plus d times, if we start from the first term, we have to take 1 away from our n, so n minus 1. So again, just substituting in the numbers, y is equal to 10 plus 10 times n minus 1. If you started from the 0 term, the candy would be 0. And the other formula would just be y equals 0 plus 10n, or just y equals 10n. So use a formula to figure out how much candy he has on day 30. Well, I'm going to use the explicit formula. So I'm going to use our first one right here. So y is equal to 10 plus 10 times. I'm going to substitute 30 for n. So 30 minus 1. So then this is equal to 10 plus 10 times 29. And then that is equal to 10 plus 290, which is 300. So we have another problem here, and it just says Augustus looks in the mirror and decides he's gaining weight. He is afraid that all the candy will make it worse. His parents tell him it would be okay if they gave him just 1 candy on day 1, 2 on day 2, and then keep doubling it. So first, I'm going to model this with a table. So I'm going to put day and then candy. I'm going to put day 0 and then day 1, he has 1 candy. Day 2, it doubles and it's 2 candies. Day 3, it doubles and it's 4. And then day 4, the candies double and it's 8. So if you look here, this is going to be geometric. And my common ratio is 2 because we're doubling. And I know that u sub 1 is equal to 1. And if I work backwards, we also know u sub 0 is equal to 1/2. So now we're going to model this with an explicit equation. So there are two really forms that you can use if you start from the zero term or from the first term. So the first one, if you start from the zero term, y is equal to u sub 0 times your common ratio to the n. And then you could also start from the first term. So y is equal to u sub 1 times r, but now you put to the n minus 1 power. And I was really impressed that a lot of you guys came up with this independently from your knowledge of exponential equations. So in looking at this, you could have y is equal to 1/2 times 2 to the n, or y is equal to 1 times 2 to the n minus 1, which would just simplify that 1 can go away. So y equals 2 to the n minus 1. So now in using our models, we can actually use both if we want and plug in 30 for n. So to show that they're equal, so y equals 1/2 times 2 to the 30. I would use a calculator. You can use Desmos there as well. So 1/2 times 2 to the 30. And that gives me, let me just write that down, 536, 870,912. Putting in my commas, it's 536,870,912. And then to just show that that's equal over here, we would just go y equals 2 to the 30 minus 1 power, which is 2 to the 29th power. So we just go 2 caret key 29, and we get the same answer. So now write both a recursive and explicit formula. So our explicit is just y equals 1/2 times 2 to the n. And then remember our recursive, I will write down the general form. We just define our first term. So I'm going to say u sub 1 is equal to 1. And then here our general form is just u sub n equals r, the common ratio, times u sub n minus 1. So I just plug that in and we say u sub n equals 2 times u sub n minus 1. Moving on here, this is a little bit more challenging of a program, or of a problem, and I like it. So Augustus is generally selfish and somewhat unpopular at school. He decides that he could improve his image by sharing his candy with everyone at school. He starts with 100,000 calories, and he gives away 60% of the calories each day. Although he is earning more calories, although Augustus may be earning more candies for his homework, he's only giving away the 100,000 that he started with. So how many pieces will he be left with on day 4 and then day 8? So first of all, let's look at this. If he's giving away 60%, that means he keeps 40%. So if I change that 40% to a decimal, that is 0.40 or just 0.4. And that tells us this is going to be geometric with r equals 0.4. So in looking at this, this is geometric. U sub 0, when we start, is going to be our 100,000 candies. And then r is going to be 0.4. So our equation would become y is equal to u sub 0 times r to the n, or y is equal to 100,000 times 0.4 to the n. So now we just need to answer our question. So day 4, I'm going to use that equation and put in 100,000 times 0.4 and then raise it to the 4th power. And it's 2,560 is all that he has left. And then we also have to do day 8. So again, using that equation, 100,000 times 0.4 to the 8. And we get 65.536. And then again, to model the candy that he would have after each day, we'll just use an equation. Y equals 100,000 times 0.4 to the n. And then how many days until it will be gone? Well, I'm just going to guess and check. So on 8 days, he has 65 pieces of candy. So if you press second enter, I can just go back and say, well, what if it's 10 days? Nope, he has 10 pieces of candy. So I'm going to guess maybe 12 days. 1.67. All right, maybe 13 days. 0.67. So let's see about 14 days. It's also a fraction. So I'm going to guess maybe around 13 days. So between 12 and 13 days.